Hey, good afternoon, everyone. Good afternoon. It's a beautiful afternoon from here, and we are glad to have everyone on the call. Okay, so as you join, kindly drop your name and then the community, your local community. So if you belong to the campus community in Ilorin, for example, so you can just say Ejumala Sonloku. I'm just using myself as an example now. DSA Ilorin, and that means that you're joining from Ilorin. Okay, it belongs to the community in Ilorin. And then if you're joining from a city community, you can also drop the city community that you're representing, okay, or that you belong to. Okay, so, for example, the Jumala Sonloku, DSN Ilorin, DSN Lagos, DSN Ota, DSN. So please let's do that. It actually helps us to get us really prepared and then make things available for us, resources available for this training. And so without taking much of our time, I would like to welcome everyone once again to this call. Okay, so we have our tutor facilitator for today's training. It's a training and it's going to be hands-on. Okay, we have in attendance already. And then before I hand over to him, I would like to share some information with us. Okay, so we expect everyone on this call to register for Moja Hack. So Moja Hack is a yearly hackathon for African data scientists to collaborate, work on a particular task. So they are in different levels. We have beginners, we have intermediate, and we have advanced. And then as data scientists, the largest AI learning community in Africa, we prepare community members to be ready for this task, and not just to be on the leaderboard, but to come first, to actually submit good solutions on this hackathon. And so please, we expect everyone on this call to register by using this link. It will be dropped on the chat box. So if you have not registered, we expect you to register. And if you are registered as a data scientist network community member, you're expected to have DSN at the back of your name, as you have seen on the screen, Tejumala_DSN. And then after registering, and we expect each community to also have a team. For example, we expect DSN XU, DSN Unilorin, DSN Funab, DSN Foot Lokoja. We expect all our community to also have a team. So after registering, then you create a team, collaborate together to solving the solution. So we expect all DSN communities to form a team for this hackathon. So I give an example. We have DSN XU. So DSN XU is now belongs to the community DSN XU, who represents DSN. So we expect all our communities to also do the same. And if you are going as individual, then you should add DSN at the back of your name, at the back of your username, in the username, to help us to actually track and also give necessary support. Okay, so without missing much of our time, I would like to introduce our speaker for today. Okay, and it's none but he's a Zambia ambassador. He has been a Zambia ambassador for a while, and then has been doing very well in the AI ecosystem. Was part of those that was in the Bahex in Ibadan. It's part of the organizers that make sure that things were done very well. And so I'm glad to invite keep the mic now. Okay, he's also a very good friend of mine, Israel. Odaijo. Yes, Odaijo Israel. So please, Pastor, pardon me if I did not pronounce your name very well. So over to you, Israel.
Yeah, thank you so much, Teju. Good afternoon, everyone. It's amazing to be on this call, and I want to appreciate DSM for the privilege to share at this point. So I guess that you helped me control the screen from your end. So I'm excited that it's another time of the year for Umoja Act 2023, and I'm sure that a number of people on this call have actually registered or planning to register because the hackathon is just a week to go, March 18th to 19th, and of course, Nigeria has always been a very amazing player in relative to the success of Umaja Arc African. This is more like the third edition, and I want to encourage everybody on this call to do register. I know Teju shared that earlier, and I'm sure that the link for registration will be shared on the chat for everyone. All right, so we can move on now. All right, so a bit about me. My name is Israel and Odiajo. At the moment, I work as a data coach at Joint Momentum at United Kingdom, and also serve as data lead for Global Edge Technology. I do a number of things around data, and I also consult with NMX Consulting Limited. And at the moment, I'm a Tableau Data Developer Ambassador for 2022. Also, last year, I was also a certified TensorFlow developer. Just like Teju mentioned, I've been a Zindi ambassador for about 3 years. Also, I'm a member of the Adenia community too. So it's a privilege to be on this call with everyone. All right, so why are we here? So we can move on here. All right, so this is an overview of our conversation this afternoon. So I'm going to be doing a bit around the overview of Umaja Arc Africa. The data already did that already, the kind of categories of problem and some notes about it. Also, we will also be getting, a bit into it. I know a number of people might just be starting, people might be experts in this field. Then we just talk about some of these things. Same thing, we're also going to explore why competitive data science is also important. Then we move to the hands-on section where we build like a machine learning model and see how we can improve that model, with different approach as time, we serve for us on this call. All right, so we can move to the next slide. Thank you. All right, so just like Teju mentioned, Umoja Arc Africa is an annual machine learning hackathon. It's an event because before we start the hackathon, there is a number of speaking engagement that happens. And of course, this brings together data scientists, machine learning engineers, and researchers from across Africa to solve real-world problems using machine learning. And that is one thing we want to know, that we want to solve a problem that focuses directly on Africa. And beyond winning the prize, this is like the focus of Zindi as a community, right? So I also want to encourage us all to make sure that we also contribute our quota in seeing that Africa gets better. Early this morning, I was checking through Zindi platform and I noticed that they have started sharing like an overview of some of the, program, some of the kind of hackathon they're going to host. And I saw this morning that one of the beginners, task is to build a machine learning model that can predict the level of CO2 emission, all right, in Africa. And that's to tell you that one of the things that the community is doing is to see that we are solving real life problems. All right. So we can move to the next slide. Okay. So during this Umoja Arc Africa, participants can form teams, just like Teju mentioned when we started. You can form teams. You can work together to develop innovative solutions to a variety of challenges, ranging from predicting, traffic pattern in cities, in identifying what I'm saying here are things that have been done in the past, just to give you an overview, identifying fraudulent financial transaction. I know at the moment there is like a practice, tax around that talks about banking, account and all. The event typically takes place over several days, like I mentioned earlier. It's a 2-day event and includes a series of workshop, talk, and the core of all is the Umaja Arc, which is the competition. Participants have the opportunity to learn new skills, network with other professionals in the field, and potentially win prizes for their contributions. All right. Please, we can move to the next slide. All right, so at the moment, that's a bit about Omajak Arc, and at the moment, I'm going to be saying things around machine learning, which I know many of us are familiar with, because that's really what we want to do, in the hands-on section. So for people who are just starting, machine learning is a subfield of African artificial intelligence that involves the development of algorithms, models, and enables computer to learn and improve from experience without being explicitly programmed. So ML helps us to learn from data, use some statistical techniques to improve their performance over time. And of course, this is one of the things we're going to see when we start the hands-on section. Machine learning helps the computer to learn a pattern from a data such that it begins to improve the performance over time. Yes, please, the next slide. All right, so like we know, we have a number of types for machine learning. We have the supervised learning, we have the unsupervised learning, and we have the reinforcement learning. So what we'll be doing will be more around supervised learning. And I know that with what I've seen on Omaja Act platform, Zindi generally, most of the problems that we will be expected to solve are always around supervised learning. So what does that simply mean? It means that we want to involve ourselves in training a model on the labeled data. What are we saying when we say labeled data? That implies that we actually know what our target is. Just like I mentioned, can we predict the CO2 emission, all right, in Africa? We know what to predict. We are not trying to do a guesswork. We are clear about what to predict. And of course, the algorithm learns to make prediction by finding patterns in the training data. All right, while the unsupervised learning a bit different, we are not too sure about what the target is, but of course, we have the input data that we cannot begin to find pattern or relationship without any guidance. When we say guidance, that is, there is no template, there is no pattern, we don't have a trained process before now, then we just want to build and assume that this is our target and be able to bring up something, right? While the reinforcement learning, we are all familiar with ChatGPT, and that's just a picture of what reinforcement is. It's about involving an agent to learn from his environment by taking action or receiving feedbacks, right? So your agent learns to maximize a reward signal by exploring different action and learning from the consequences. All right. Yes, please, the next slide. All right. So most of the problems we'll be solving the supervised machine learning, stage is more around the regression and the classification. Yes, I know there's clustering, but most of the tasks that I've seen on Zindin platform are focused on, supervised machine learning, specifically regression and classification. And so these are just like the two broad guys. The regression involves predicting a continuous values, while classification involves predicting a discrete class or category, right? If I ask you to predict if a student is going to pass an exam or not, that is a classification problem. If I ask you to predict the sales, all right, or just like the task we'll be doing in this call, the sales of a particular product in an outlet, that means I'm going to be doing a regression problem. All right. So this is just for information's sake and just carrying everybody along. You can please move. All right. So there are a number of models that we can build to ensure that we are building a machine learning model, right? Linear regression is one of the easiest or baseline model we want to try out. And of course, there are a number of metrics. Metrics means we want to evaluate, is this model performing well? And there are a number of, linear regression model metrics that we use to check performance. One of them is the mean squared error. We have the root mean square error. We have the R squared score. Pretty much we're trying to understand what level of errors do we have in the model that you have built. So one of the jobs we want to do when we're working with regression problem is to ensure that we want to reduce as much as possible the error. If the error is very wide, that means the model is not doing well. Why, if it is, of course, that's pretty much what we talk about when we are building a regression model. And of course, we have the polynomial regression. It's just an extension of the linear regression that captures non-linear relationship between the input features and your target outputs. All right. The metrics used for evaluating is same thing as your linear regression model. All right, please, we can move on. All right, so we have the classification model, just like I mentioned, that we pay attention to the supervised machine learning, which is regression and classification. So under classification model, we have the logistic regression, we have the decision tree, we have the random forest. This is just to mention a few that we can work with, all right, if we have a task relative to classification. So the logistic regression talks about you building a machine learning model with binary class tags. And of course, they are pretty much for that. But we know that there are some taxes that might mean us to build multi-class. That is where you can use the light of decision tree. You can use the light of a random forest classifier, right? And of course, there are numbers of metrics that we can also use to that regard. We have the accuracy, we have the precision, we have the recall, we have the F1 score. At times, you want to also draw the confusion matrix. You want to see the classification table, reports. It depends on any approach that you are really comfortable with, that you can also interpret, to mean that you can interpret what your model is saying. So that's one very important thing that we do to ensure that we understand how our models are performing. All right, so we can move to the next slide. All right, so I also like to talk about, the journey to doing that science competition. So it's a different ball game for many of us who work in the industry, and we just build simple model to be able to test what we are doing, as a data team. But at this point, these are some of the things that you have to pay attention to, as it were. So the first thing is, which is always like the general approach, is what we call the simple baseline model. All right. Even most competitions, most hackathon will always give you more like your fourth baseline, notebook. So if you go through the notebook, you'll be able to build your first model. All right. So this is just like a look into your data, then create a model without any data cleaning or any feature engineering. We are not doing anything too serious. We're just trying to follow the simple process, the simplest process, loading your data, filling missing value, building your model, and submitting it. You're not doing anything. You're not even trying to understand the correlation. You're not trying to do some statistical, differentiation on your data. You're not trying to get any other information. You're just basically trying to just run through your data in its simplest form. Then you are building a model. Then you're trying to see what the baseline. What that simply means is that if anybody follows that same process, this is what the submission score will look like. All right. So that's one very important thing to take note. But now moving forward in your journey, especially when you're competing, is that you have to understand the problem, because there are things you will have to introduce when you're trying to do your exploratory data analysis that might not really be from what the problem is really saying. At times you want to do your research and see what people are doing, what people say about the subject matter. And these are very important things because it will widen how much feature engineering you'll be able to do. I'm just going to explain each of these guys when we start the hands-on and we see the reality of how we can use them for improvement. But key thing is that you have to understand the problem, what am I trying to do, what is the best approach, what is the best process, what is the standard way of building my model, of doing my cross-validation. So another thing is that after you have understand the problem and the data, so that you can create a good validation set. Now, what's a validation set? This is you trying to understand how your model performs. Can I trust this model? Is this model giving me the expected results? So validation is one key thing you do, especially when you are trying to train a model, then you have to validate the performance of that model. A good validation set is a must. So I must say that only then can you trust your local result. When you are competing, that you are getting a good score locally on your system does not completely guarantee that you're going to get that kind of result. You're going to get things like saying that there's an almighty falling on the private leaderboard, right? That is just because they've not paid attention to their validation. So your cross-validation is one very important thing you have to pay attention to when you are building model for competitions. People will continue to fall from one position to the other, when we are competing. So people just want to submit and they do not pay attention to some of these things that will help them perform and retain. Just like Teddy mentioned, we want that people from our community participate and of course win. And that's why we are sharing some of these tips that could help, every participant to enjoy the process. All right. So like I mentioned, else that will lead to, almighty falling on the private leaderboard. I know many of us are familiar with every hackathon platform do have the private leaderboard and also have the public leaderboard, right? So this is just a picture of what your model looks like at different intervals. So the public leaderboard is what we all have access to when we start the competition. Most competition, it's more like a 50-50 thing. Some will be 30% that you are seeing at the point the competition is active. And when the competition is no longer active, that is, the competition is over, then you now begin to see that every of the data is tested on the 100% of the test data. Your model is being tested on the 100% data. So at that point, it is difficult to know the volume of data your model will be tested on. So it's better that you pay attention to that when you are building your own product. Another thing is that you have to be able to build varieties of models. Just one model will not do the work. You have to experiment as many models as possible. You have to do the likes of gradient boosting models. You might even need you to do some neural networks. I remember there was a competition I won around something very close to the task that we are doing at the moment that I mentioned. I saw this morning on Zindi platform, very close to something around with satellite images. So I knew, though it was not completely, it was still more like a textual data, but it was more around the tax that they just mentioned on the platform now. But the emphasis was that at the point after I built a number of models, so I needed to try out neural network to just see how much my model was. So the emphasis is you must be willing to try as many models as possible. It's a long hackathon actually, and that is why this class is important. At times people get tired after submitting 1, 2, 3 submission and they feel there's nothing else to do. That's what I'm going to be giving from like a real life experience personally, the things I do when I'm building models and how it has helped me. So another key thing is that you must be able to learn assembling. Assembling gives you the edge to win a competition. So at some level, because a number of people, if we watch also on the leaderboard, you notice that people begin to have the same kind of score. All right. Somebody has 0.5, somebody has 0.5, has 0.5. But it's possible that somebody who has 0.5, all right, can improve to say maybe like 0.01, which is an edge over someone who has 0.5. So the emphasis here is if you are able to build several models, you can definitely try to like make your own model, all right, perform much better by combining your scores together. The models you've been building, you're trying to combine as many models together. And that is where assembly plays out. And it's one technique that I want to advise that you try out. And of course, I'm going to still do a walkthrough of how you can use some of these models, right? All right, so we can move on. All right, so one other technique that makes you, as very important to the journey of doing data analysis, especially for competitions like this, is that you must be able to use some of these feature engineering techniques. Cutting across imputation, how do you handle missing value? Categorical encoding, you have features that are objects that are not numeric. How do you handle them? You have features that are showing outliers. How do you manage that? Binding, scaling, how do you scale your numeric features? How do you transfer them? How do you do feature selection? How do you do feature grouping? These are like process that you want to try out to ensure that you are doing as much as possible to improve the kind of data that you have so that your model can perform better. All right, we can move on, please. All right, so what are the benefits of participating in competitions? So one of them will be, the biggest of all is that you get rewards and winning exciting prizes. I know that in all of this competition, this competition has 3 phases and they are willing to give about $10,000, across the 3, tiers, the beginners, the intermediate, and the advanced, right? So that's one very important thing. The second thing is that you're competing with others across Africa. Then you're also learning because people, you will have to try out many approaches, right? You want to try out different approaches and see which one works better. And that is one very important thing. And that's also another way to even learn. And the last part is networking. You get to meet guys from Uganda, guys from Kenya, guys from Ghana. That's a big network, right? And that is one thing that makes Umoja Arc standard and of even every competition standards as it were. All right, please, everyone. All right, so before we go to the hands-on, it's going to be a business problem from Bigmart, and we're going to be trying to predict some sales. But I just like to take some questions. If there are questions at this point, something you want me to clarify before we move to the other section, right? Any question from anyone? You want to clarify something on the chat, you could just do that before we move to the second. Okay, Joy Amuson is raising hand. I don't know if the admin will help me allow to speak or she needs to comment on the chat. But what format are we using to take the questions? Study there.
Okay, hello everyone. So anyone with question can just drop it on the chat box. So your questions will be picked from there.
All right.
Thank you.
All right. Thank you very much. So we can just continue from this slide. Just to show something before I start sharing my screen from my end. You can move on, please. Next slide, please. All right, we can move on. All right, so this is the task we'll be doing. We just, as data scientists at Bigmart, collected 2013 sales data for 1,509 products across 10 stores in different cities. Also certain attribute of each product and store had been defined. So now your aim is to build a predictive model that predicts the sales of each product at a particular outlet. All right, each product at a particular outlet. Using the model, Bigmart will try to understand the properties of the product and outlets which play a key role in increasing sales. These are, so if you want to get access to the source code that we'll be using in this class, I know that the team will help me share these in the group. You can also follow through from your end. So I think I should just take some of these questions before we move to the other part of this webinar. Okay, so somebody say, how do we really know that a person is really a beginner, so we won't have somebody from advanced category competing with we beginners? Well, I guess that Zindi will be able to do that themselves. And trust me, there is really no competition you can call beginner or advanced, really, trust me, because the process has not changed. Before anybody can win any competition, is a lot of work. But the reason why we try to separate that is because, okay, I just really spoke about what the intermediate and advanced will look like. One, most time at the intermediate and the advanced level, the competitions will be, the data will be a bit more complicated. And the kind of models that you're expected to build, it could build that it is not just the textual data that you're working with, just the normal tabular data rather. You might be doing something around NLP. You might be giving tasks around computer vision. That is like what's separated really. I'm sure that the beginners will always be tabular data around supervised and or unsupervised learning, or supervised learning rather, which can either be regression or classification. Right? That's like the only thing that is more like the difference. But they try to segment that to encourage people who are just starting to at least pull into the beginner. And trust me, even over time, we've seen that it is the guys who have been very active on Zindi before time that emerge at the end of the day. Right. So that's like the beauty. I said that one of the benefits was that you'll be learning and competing. So the number of people who have been on Zindi for 4 or 5 years, and of course, I mean, they have the energy to be on many platforms to compete, right? And they've seen they work with number of data, they've tried different process on data, so it's so much fresh on their head, all right? But in all, what is most important, especially if they're just starting, is be a part of what is happening, try and see how people are solving problems. I know at some point they used to, I don't know if they still do that again, that at some point they used to review the winning solution so that you can go through it and see the approaches the person used. Because the emphasis, everybody who has competed has solved one problem or the other. Everybody who has competed has solved one problem or the other. They build a very, robust model that is usable at that point. But most time, or the issue will be that somebody has tried several processes, somebody has tried other methods to improve the baseline that we can all by default build. All right, so that's like the difference most time. I don't know if that answers your question. Okay, somebody said, how do we get the code? Okay, I think Teddy did that already. Okay, what's the best way to win the competition? Yeah, I've mentioned it already, and these are some of the things. Maybe you want to go through this again. The best way to win the competition is to compute, and there are a numbers of approaches that you should follow, and I've mentioned them in this slide. And I'm going to also do that in the live section we're going to go into. If you're going to win a competition, there's more like a guide of the actions that you should perform. All right, there are actions to perform. One of them is going to be EDA. You have to explore your data, understand the business problem, because that will give you a leverage on the possible options of what you can do. All right. Do your feature engineering. your feature engineering could be about imputation, could be, I mentioned it when, we were doing. So if you can do those things perfectly well, you can do your assembling. Assembling, there are two major ways of doing that. You're stacking, you do blending. And of course, I'm going to do some of them, in the class today. But the emphasis will be that you can get access to the source code that you can practice at your end, because we're going to be solving a real life problem today. Please, if you are good in enforcement, I guess that's not a question for me, just a general information. Okay. Could somebody say shared? Okay. I guess those are the questions. Okay, what is assembling and how does it gives you an advantage in the competition? So like I mentioned, we all could just have 0.5, 0.5, 0.5, 0.5 as our score. And trust me, that is more like what we can all get at that point, right? That is just like what we can all get at that point. But the good part of it is, if you are very good with assembling techniques, such as stacking or blending, there is a way you can give you an improvement to say you now have 0.51, because you have had several scores, you combine them together. There is a pattern of doing it. You combine your different, scores together, and you divide it by a particular amount or number of scores that you've done. And there is a way it gives you an advantage, right? Over others, really. Someone said, what is the best tools for AI? Data science. So what are the best tools? Now, I mean, it depends on the approach you're using to learn. It could mean that if you are doing a programming approach, the best language I would advise that you learn is Python, which we're going to also do a bit of on there. But if you're trying to do the business intelligence way, where you're trying to use a tool like Tableau, like Power BI, like Looker, you can use those tools basically to manage your data journey. And of course, SQL is one very important thing you also want to learn. I guess I should just answer that as I move on. So any other question before we just move from here? Okay. So please, you can also try these. You can try this URL to get access to. So I guess I don't know if the admin can give me permission to share my screen now.
Okay. Yes, you have the permission already.
Okay. Thanks so much.
So I'm going to stop sharing, and then before, okay. So before you just share your screen, let me just pass this information across to everyone. Okay, so this is a series, and then this is just the beginning of it. Okay? And we know that Rome is not built in a day. And so having this in mind, we are going to be having series of trainings like this before the hackathon. So I'm still going to have another one this week that Israel will still be participating. And so please watch out and then make sure you register so that you can get all correspondence. Thank you very much. So it's going to continue next week. And there's going to be a closed user group. And that's why it's very important for everyone on this call to register for this event. There's going to be a closed user group where we have access to our mentors, to the facilitators that can answer questions, and then any question that arises in the course of our preparation for Moja Hub. So thank you very much. So Israel, please, you can share your screen so that we can continue.
All right, thank you very much, Toji. I guess everyone can see my screen now. Please can just indicate in the group so that I can continue from my end. Oh, thanks everyone. All right, so I've prepared a number of notebook that we can run through from an hackathon I was part of. And that's why I was saying that it's always very good that you participate in hackathons. You see what people are doing, and at the end of the day, there was more like a blog that showed processes we can follow. And that's why I'm sharing this, on this call. All right. And time will not permit us to go through all of them, but trust me, you have access to my GitHub repo, and you can always clone these and try it at your end. But of course, you can always shoot me questions, and in my DM, I shared my LinkedIn name the other time, Odiajo Israel. All right, of course, and I know that there are a number of amazing mentors with DSN that you can also reach out to. And of course, at the end of the section again, I'm going to share my details in case you have any questions. All right, so problem statement, like I mentioned the other time, I won't just emphasize that again. But the emphasis is that we want to predict sales. So if we want to predict sales, we're going to be doing a numbers of things around regression problem, right? We're going to be predicting continuous values. It's not a classification problem. So that's like the first thing to know that you are in the space of data. You must know the kind of model you can build, right? So that's like the first thing we're going to do. So this is more like a step. Just like somebody asks, how do we? These are the steps you need to follow through. So the first thing you need to do is to import relevant libraries. All right, there are a number of libraries that you will need. And of course, this time we will not permit to start talking about peculiarity of each library. But as I use them, I will try to talk about why I'm using them and what I want to achieve for importing them. All right. So I've imported a number of libraries here. I imported matplotlib.python plot as PLT. I imported pandas as PD. I imported numpy as MP. I imported seaborn as SNS. So these four libraries I've imported. Two of them will help me to do numpy will help me to do my mathematical operations, the light of your sum, everything that you think about mathematics that you want to crack your head to really do. All right. NumPy will do that for you, with less stress, right? Why pandas? Pandas is more like the advanced Excel, what I call it, advanced Excel, that is really going to help you to like dig, your data and see some information from them in the tabular format. So most times, if you don't see anything in table format, pandas is helping you to do that. Pandas, you can try to a data frame where you can say a series of information. You can do a group by, there are a number of things you can do with your pandas. And most importantly, at this point, is that pandas is that library that enables us to be able to load, that will enable us to be able to load our data sets. Our data sets. Why the other guy, the scikit-learn, all right, all of the processing I'm trying to use there pretty much is for building models, is for doing my pre-processing of my data before building my model, all right, and of course for evaluating my model, and of course for splitting my data to a train and test, all right, to train and test. Of course, why do we import? One is in case there are some things that happens maybe by the compatibility of the libraries have been stored locally and something is happening and it's trying to give me like a warning. So I just ask you to ignore it. All right, because warning is completely different from errors. So I just want you to ignore it. All right. The next thing to do once I've imported the necessary libraries is to read my data. So most times, especially in hackathons like this, you're going to be having series of kind of data. But in all, you're going to have a trained data, you're going to have a test data. All right. Also, we used to have submission file. It's also a CSV file. Also, we used to have what we call like the variable definition, file. And of course, as time goes on, we're going to explain what these guys do. But for the train and the test, which is always what you should look out for, all right? So of course, and let me also add, this is where the advanced thing plays out. So for advanced, for instance, they can try to like have different kind of data that they want you to combine together before building your model. So that might need some technical, expertise, which they may not put on the beginner. In the beginner, they'll just give you the train, the test, the submission file, something that is a bit very straightforward. But in the advanced or in the intermediate, they can give you series of data, and they want you to like combine them together, try to see the ones that are important before you even build your model, right? So that's one picture. Then because we are working with our train and our test, we always know that in our train, we will always have our target because we are building a supervised learning machine, right? We are building a supervised machine learning model, all right? And in our train, if you look at this data set, for instance, we have about 8,533 in our train, and we have 12 columns. While in our test, just a portion of data that we are going to be using, to test the model that we built, has about 5,681, records, and has 11 columns. Now, the question is, what's the difference between them? Why is it not having 12? Because when we are building our machine learning model, our target will not be in our test data. Our target will not be. So most time, put that in mind. So for people who are just starting, you should know that the columns, especially in the column, if you're having 12 in your train, you know that by default, you will have 11 in your test. If you're having 10 in your train, you should know that you're going to have 9 in your test. Why? Because you know that your target will not be in your test, because that is the value you now want to like predict it by your test, features. All right. That is more like your target. All right. It's the same that I'm saying. All right, so from what we have here, I said we have 8,523 rows and we have 12 columns in the train set, whereas in the test set, we have 5,681 rows and 11 columns. Now, the next thing to try to understand, depending on any approach you try to do, yours is to understand if they are missing values. So for me, I did the ratio of non-value. Non-value means missing value, right? And I'm trying to check the percentage of missing value. You don't necessarily have to do percentage. You can just do your norm is none.sum. I mean, they're just different approach of doing the same thing. That's just a picture of what I'm trying to show you. So when I check through my feature, I can see that I have about 17% of missing value in my item weight, while I have about 28.3% of missing value in my outlet size, right? While others do not have any. So the next thing I want to think about is my text data, because whatever, and that's very important, is that I combine my train and my test together so that I do every pre-processing on them together. But if I'm trying to do them one by one this way and I did not combine them together, it's important that whatever I'm doing, really, whatever I'm doing in my test, in my train, I should replicate that same process in my test. If I feel something in my train, I should do it in my test. And the reason why I'm checking them together is because I don't want to make the mistake of doing something on my train and not do them on my test, right? So almost same thing. And if you look at that, it's almost the same two columns that are having missing value, right, in my test too. So what I have there is that 17% and 28% of missing value in item weight and outlet size column, respectively. The other thing I tried checking is the number of categorical features that I have and the number of numeric features that I have. What are categorical features? They're like the objects guys. The guys that are asked when you check their information and it's showing you objects, that shows that they are categorical feature, right? While the ones that show you integer or show you floats simply mean that they are numeric. These are just me trying to go through the data one by one. No, this is very important that you do them because you have a long time for the, for the competition. It's almost like a 2 days, competition. So if care is not taken, and if you do not pay attention to the data first, and you are just interested in submission, that's why at times you see that people do not submit so quick. You see somebody submitting just 1 and 2, submission on Zindi or on Kaggle, and you see them winning the competition. Why? It's because they are paying too much attention. They were not just focusing on making submission. They are doing all they could to ensure that they are building the right model, that they understand their data and all of that. And this is one thing I want to urge us, that as we, start or as we continue or as we build our models, we should pay attention to our data. So don't feel, these are basic things. Yes, they are basic, but they help you to know what and what to do, all right, over the data sets you are working with. Right, same thing I check, I've told you I'm working with train and test data, so I check through the same thing for my test data. How many categorical features do I have? How many numeric features do I have? Almost same thing. Next thing I did was to do some data cleaning. And the first thing I want to do here is to undo missing values. All right. So I check again the exact number of values of my missing value. So in my item weight, I have about 1,000 plus missing value. In my outlet side, I have about 2,000 plus missing value. Same thing, my test, I have about 976 missing value. My item weight in my outlet size, I have about 1,000 plus missing value. All right. The next thing I did was to look at, I plotted, because they are both numeric feature. If I'm saying that, no, my item weight is numeric, my outlet size is categorical. So because it's a numeric feature, I check the item weight and I try to use the box plot to see more like the mean of this, and I can see what the mean of this looks like. It's about 2.5 or thereabouts, right? For my item weight, which has value that range between 5.0 to about 20.0 plus, right? That's what I did here. Same thing, that's what I did, just trying to check through what I have here. And what did I do? So I tried to fill with the mean. So generally, statistically speaking, and best practices is that if you have numeric feature, you want to fill it with the mean, right? That's like one approach that over time you will learn it because you are practicing, because you are trying it out, right? You will fill numeric feature with mean most of the time. All right, that's what I just did here for my train and my test. The outlets, like I mentioned, the outlets is not completely meaning that it's numeric. So I have to check it through using value count, and I noticed that I have my outlet of medium, small, and high. Same thing, my test, I have my medium, small, and high. So what I did was to fill it, can you see this? Was to fill it with my mode, the mode of the distribution. So if I want to take note of that, it's more like the best practices, right? So the next thing I did was to check through my data, and I have item identifier, I have the item weight, I have the item fat content, I have the item visibility, I have the item type, I have the item MRP, I have the outlet identifier, the outlet establishment year, the outlet size, the outlet location, the outlet type, the item outlet sales, which is our target. All right, don't forget that. The item outlet sales is our target. Based on this other feature, can we then predict what the sales of that particular product or that particular item is going to be, right? That's what we're trying to do. So another thing I checked through was the item fat content, where we have the low fat and we have the regular. Now, one key thing here that I looked into was the irregularity of the values that I'm storing. So there are places where, and of course, it's not showing reflection here. So if you check the data before doing what I'm about to do here, you're going to see that there are some points where we have LF. LF simply also mean low fat. REG also mean regular. So I'm trying to like ensure that irregularity does not affect what I'm doing. So all I did was to replace it to say low fat whenever I should replace whenever I see low fat in lowercase as low fat, whenever I see LF as low fat, same way, and whenever I see reg as regular. But you know that for me to do this, that means I must have taken time to check the data to see a number of cleaning that I need to do. And I did in place true. Why am I doing in place true? So that whatever I do at this point is permanent into my train item fat column. I did the exact same thing for my text data. I replaced it and I used in place true, meaning that it should remain, all right, at every time. It should be there permanently in my text data, specifically the item fat column. The next thing I did was to check what the data type was and ensure that the data type should be seen as a string, right? So the item fat, I decided to do a count plot, and I can see. So the low fat is the one having the highest, and of course I'm using a count plot as about 5,000 plus, of course, record that we can see here, while we have the regular, much more above 2.25, much more above 2,500, right? That's what I have, close to something around 2,700. That's what I have here. So same thing, I was trying to understand every of my, data. I checked through my train to check the item type. So I was trying to understand every of the feature. Especially when you do not have too much features, I advise that you take out time to understand, especially the categorical ones, which will be like a category. It has a number that is going to show. So I advise that you check out time to look at them. So I did the unique to see the number of unique items that really are, even though we might have so many items showing up. So I checked the number of unique. I checked the number of unique too was 16 item type. What I did was to now plot, a count plot for my item type, and I can see varieties, of items from diary, and I can see from here that we have so much item, all right, to be what fruit and vegetable, snack food also doing very much well. Another thing you can do at this point is you can decide to order the results you are seeing, so that in the particular order you say either descending order and ascending order for easy identification. So what I can see as insights here is that fruit and vegetable are largely sold, as people tend to use them on a daily purpose. Also, snack foods too as a good sales, household too as good sales. Right. The next thing I checked was the kind of outlet size that we have. Like I see that in the data we have so much outlet to be medium, all right, followed by small, and we have a little of I out there. So now I'm checking a number of information. The outlets are more of a medium size based on the visuals that I did. Another thing I checked was the outlet location type. Why are these things important? They help you to put the data in mind. They help you to understand every single feature in the data. Just building the model is not what really makes sense, right? If I can use that word. But what is most important is that you, as the one building the model, can explain the process. Most times it's not about building the model, it's about using a very good approach. That also helps you as a person, because you'll be able to defend whatever it is you build. But you are so much conversant or so much concerned about building models or meeting. I know a lot of people do that. Most times you just want to build model, you don't want to submit. Yes, it's a good approach, but the reality is you want to also pay attention to the processes. And like I've told you, you have a number of sorry, I think I saw a message that needs my attention. Somebody is asking me to put the link in the group. I guess I need to do that so that Please a moment. We're going to drop the link to the group. All right. Okay, good. Perfect. All right. So I advise that we try to ensure that we do some of these processes. Same thing, I check the outlet type. I can see that supermarket type 1 has more like the higher sales, if you can use that word, relative to your targets. I did my bar plot also checking the item type over item outlet sales. All right. And the products available were fruit, veggies, snack food, but the sales of seafood and starchy food seem higher, and hence the sales can be improved with having stock of products that are most brought by customers, right? So when I tell people generally in the data spaces, not every problem really needs building model. Some of them just need some level of analysis. Some problem with this now, for instance, we've solved this problem, all right, using the simple analytical way, just doing our IDE. But because the tax want us to do more than that. So from this now we can see that if we want to talk about the sales that we have been having, we can see that we're having more sales as seafood and starchy food. All right. That means if we are making more sales at seafood and starchy food, that means if we have to have a new outlet, we should have more of seafood and starchy food. We should have more of that in all of our stocks. All right. And of course, we can be sure that customers are going to buy it. All right. So, but then because we have more to do than that, the next step is going to be that we should build machine learning model, right? And the first thing to do, where you now know that it's not just about visuals, I need to go further to build machine learning model. So my computer will only understand binaries, right? So for the item identifier, for the item fact content, for the item type, for the item outlet size, for the outlet location type, for the outlet type, all right? Those guys, they are categorical features. So, and one other thing in your feature engineering that I showed you in the slide is that we should be able to encode them as numbers, as it were, right? So we won't be able to pass them into our model. So, and that's what I was trying to do here. I decided to use a label encoder that I imported the other time from my sklearn preprocessing, and I selected every single columns that are objects, such that it looks through them and transfer them, all right, using the label encoder. Same thing, you should do that same thing for my text data, all right? That's pretty much what I did here. So I used the label encoder pattern. Of course, there are several other ways of, encoding your categorical feature. One, auto encoding is there, target encoding is there, count encoding is there. I mean, there are a number of other ways of encoding. And of course, these are also processes that you must experiment, because your data sets, each of them might work better. For this one, for instance, it might be that it's label encoding that is working. For the one you will see on Umoja app, it might be that it's one auto encoding that will be performing much better. So everything that has option, you are supposed to try them out. Don't be an hurry to feel that's the best, because the only way to see that an approach is the best really is by trying it over different options, right? So try every of these pre-processing on different options. I'm going to advise that try it on different options, right? Okay, so we did encoding for these guys, and this is what we have. You can see at this point, we've all been encoded, both the target, both my test data and my train data. The next thing I did here was to separate my features from my targets, all right? So that means I'm trying to drop, because you cannot build your model having your target with it. So my X, I'm dropping my target, which is item outlet sales, while my Y should be just the target only. And the next thing I did here was to do my validation set. Remember, I mentioned that the other time. It's important when you are building your model too. All right. So I decided to split it, by 20% of tests. That means if I'm splitting 20% as test, that means 80% will be my train. If I'm splitting by 0.3, which is 30% for test, that means 70% would be my train. Also, I introduced the random state, which many of us are familiar with. The random state gives a picture of the kind of splitting that will be done randomly, and that random value that I'm splitting into my X train, X valid, Y train, Y valid will remain as far as the random state is 22. So if I don't introduce a random state, at any point when I do the splitting again, values change, all right? That means the model performance will also change. So most time you want to introduce a random state, all right? So all I did there was to also have my X column, which I am using as my feature, which I'm using as my model. So I initialize my model called linear regression here as LR, and I'm fitting. So you fit on your S train and your Y train, then you predict on your X value, while you make your evaluation on your Y value. and the value that you get. So that's what I did here. All right. And from this result, what I did was to check the coefficient. Coefficient here is talking about important features, right? That I have. And from all I can see, so I actually plotted the bar plots. I can see that not all of the features are really very doing well, because these guys are showing negative, outlet size negative, outlet type negative, item visibility so big, showing that is negative, but item content is a bit better. Item type, I can't even see what that one is showing. It's just showing more like anything. It's so neutral in relative to the values I'm predicting. But my outlet type at a big effect, on what I'm doing. So that's what I have. I said that the item visibility, outlet type, outlet size, outlet location are the most important attribute to determine the item outlet sales based on this data, based on the model I've built. So these are things that you can now begin to use, all right, as a threshold in improving your model. So if you check the model, so I've told you after building the model, you have to evaluate it. So when I did my evaluation, so if you check through this, you're going to see that my RMSE, which is one of the, because every of the hackathon you are competing with, we tell you the evaluation to use. So it's better you use that one that has been used for the hackathon, because everything that you are doing is subjected to their own real solution on that platform. So don't use an evaluation for your submission that is not relating to, so you need to read it well. What metrics are they checking out? Very important. What metrics are they expecting me to, work with? So for this tax was root mean square error. Look at it, and this is about 1,246, and that is huge. Right? But then I've done a number of things at this point, so I can, save, the value that I have. And at this point, this is when your submission file, I told you that some hackathon will give you submission file. And this is when your submission file is important, and you want to then use that submission file here. But because at this point, you want to save and test on your unseen data, which is in your test. So at this point, your prediction will be on the test. Now that you are sure that you want to use this test, you are not using the Y value this time around, X value rather this time around that you used for the model. You want to use your test data that you have been doing the same preprocessing on. This is the only time you will need it to do your prediction. Then once you're done doing your prediction, now why is this submission file important? Because in the submission file, most time they've given you the expected outlets that they are looking out for. So if you check the submission file, for instance, let me check the submission file here. Up is somewhere here. So it's not on my local platform running here, but you will have seen that it has a format, and that's what I'm trying to call out. It has a format because there are expected IDs. If those IDs are missing, if you try to submit your submission, it's going to tell you there's an error, there's a mismatch. There are many issues that might come up. But if you don't have a submission file, you can just use the ID in your text. But most time, especially on Zindi, you always have a submission file that you can mirror for your submission. All right, and that's what I just did there. You want to pass the ID as this guy. Then the other one will then be the value that you predicted that was stored in your Y predicts here. All right, or the new one you did here. Maybe the final predict. Okay, the final prediction is what you want to use to make your submission. So the first thing we have done here is just baseline thing. They are not big deals, and that's why I said, just like somebody was asking, this is simple enough. All right, it's not bad. There's a level of reduction. 1246 is the error. It's still very huge, but our job is to see how we can reduce it. Then what other things can we try? Then that will take us to feature engineering. All right, feature engineering is also one thing we want to do. So I'm just going to move to that part. All right. So what did I do here? One thing I did again is can I determine the year of operation of each store? Now the emphasis, there is no right or wrong answer. It's all about you trying to add more data. And there is a general belief that the more your data, the more your model predicts better. Here when the data correlates with your targets. So because I think we've checked outlet establishment here and it is not useful. So what if we understand the exact number of years that a particular outlet has used? We created that in our train. We did that also in our text. So you can see that this data is 2021 was when we did this computation. All right. So that was what we have here. So another thing we did here is, okay, what if we combine a broad category of type of item, such that we're saying that in our item type combine, we want to combine to have our item identifier using a Lambda function that pass through our X to map 0 to 1, 0 to 1, of course, that's a range, such that our train item type combine, map whenever it sees FD as food, whenever it goes through all our item, that's what we're trying to say. It goes through all our item type, all right, and begins to map. Whenever you see FD, it sees that as food. Whenever you see NC, it sees it as a non-consumable. Whenever it sees DR, it sees it as what? As drinks. So we did that for both our train and our tests. What else did we do is that we try to do the location, all right, whenever the item type combined is equal to non-consumable or item fat content, all right, it should show that it is a non-edible. So you know that there is no way you can tell us the item fat content of items that are not consumable or that do not have any item fat content. So what the item fat content should be at that point should be non-edible. So that's what I did here. So that's instead of just showing low fat and regular, in a situation whereby it is not a consumable thing, it will not have a fat content, right? So I'm saying that it should show that it is non-edible. So, I mean, you want to ask me, how did we come about with this? It's about just understanding the problem, understanding this space, and the possible things you can do. That's what we did here. Same thing, we did the same thing. You should locate our test at any point in our item type combined that there is no value that looks like non-consumable item fat content, then we should call it non-edible. All right. So the next thing to do at this point, because we now have other new features that we just created, and they are categorical objects, kind of, right? We try to, ensure that they are all converted to what? To transformed by encoding them. And you can see at this time, I try both label encoding and I try get dummies, which is one auto encoding, right? Just to see I've told you, you want to try them out and see the one that performs much better. Based on what I've done, at this point, I excluded the ones that are objects. I didn't even drop anything. I just excluded them, all right, in my train and test at this point. So I followed the same process. I built my model. You can now see. So yeah, because now, I used the last one I used was one auto encoding. You can see that at some points, there are some features that are looking as if they are actually very useful for us. And what was our RSM? Look at this. I now have 1,187. From where? Look at the reduction from 1,246. I mean, that is a huge, reduction. But of course, it's still very, very big. It's still very, very big. And don't forget, at this point, I've just been using the baseline model most of the time. Everybody use linear regression. I've not done any other thing. All right. I've not done any other thing. So look at how we reduced from 1,246. Because your real job will be that if you are doing regression, is to reduce the error score. I've said that earlier, is to reduce the error score. So if it's mean square error, if it's root mean square error, if it's R square, there are different metrics that you can be asked to use. But most time when it is error, you want to reduce it as much as you can, right? That's what I've done in my first model and in my feature engineering. What did I do in my feature engineering? I just tried to understand the concept much better. I created a new feature. So in your feature engineering, most time you want to create new feature from existing feature most of the time. But does it make sense to your task? Most time you want to do addition, subtraction, division. All right, that's like the number of things, especially when you are trying to do feature engineering. All right. It is depending on the task too, but most time that is how I try to tell people. Most time you're trying to like divide something, you're trying to multiply something to get a new feature. You're trying to map like this. All right. That's what we did for feature engineering. So I guess I take question before I go to the live space. Any question so far on what we've done? Anybody? Any question on the task so far? So we walked through two different notebooks. The first one was our first model. The second notebook, I did feature engineering. I just want to do how you can try different models, then we do assembling, then we can, end this section so that I don't keep everybody, too late on this call. So any question from anyone? Okay, I guess we just continue. So if you're on the same page, can you just put a yes in the chat room? Then let me just know what you feel about what we're doing.
Yeah, sir.
Okay. Oh, great. Thanks, guys. All right. So I guess we just move to the next thing I think we should try out. And most time, like I mentioned earlier, is one model, especially when you're just starting, one model is not going to give you what you are really expecting. You want to try the journey of machine learning is about experiment. You want to try them out. So there is no wrong way. Okay, somebody's asking, what do I mean as the main aim of feature engineering? Is that I'm trying to do more like a processing of my features, not that I'm building model. I'm just trying to, make sure that I did a number of things on the kind of data I'm working with. I don't know the best way to say it right now. So like I'm just trying to make my data be in the right form. If there are features that I think they are missing, I add them by doing just what I did. There are features I think that they are not necessary, I drop them. Like that is just one of the things you are doing at that point. You're just trying to ensure that your data is in its right form. One feature is missing, and you can think about that feature that will make sense to the task you're doing. How can I create it? That is what that process is. It's all about the columns that you have. Which one is not necessary? Let me drop it at this point. Which one should I exclude? Which one should I add? And I've said most time the things you'll be doing, there are some little operations you will do. You might want to add a new feature, you might want to subtract, you want to subtract something to get a new feature, you might want to multiply something to get a new feature, you might want to divide something to get a new feature, you might want to map up, existing feature to get a new feature. Just like the one we did using the item identifier to get if a particular item is food, not consumable, and all of that, right? That is just what the picture looks like. I'm saying this way because the data will always change over time. But you know that the things is that, is there any new feature I can generate? Is there any feature I can drop? But most time you want to try to like generate new features most time. So most times it's more like, so it ends up to look as if when we say we're doing feature engineering, we're trying to add more features that does not exist before. I generated like 3 features now, and they were not in the data we worked on. So it is your engineering skill now that we want to see on your feature or on your data. So thank you, Paul. I think that's a buttress to one of the things we did. All right, thank you so much. All right, so here we want to now see, okay, now that we've tried that, we still have about 1.7 thereabouts, which is still error. Then what else can we do? I just want to show you some of the things in this notebook. Like I said, I've shared the link in the group. Please do download and practice at your end. Yeah, so let's look at some of the things that was done. All right, so at this point, I decided to also use other models. I've just used linear regression the other time. At this point, I just used other models. So at this point, I was introducing algorithms like linear regression, ridge, lasso, k-neighbor, regressor, decision tree. All right, I mentioned the name of the models. Then all I did was just to pass each of these data, all right, into my model. That's all I did. I just passed I fit it. I predicted on it. I got my mean square error. I got my RMSE. All right, that's pretty much all I did here. Then I decided to convert the models and the RMSE into a data frame, and this is what I have. So at this point, I built linear regression model, ridge regression model, lasso regression model, k-neighbors regressor, decision tree. Now look at these models. Which of them performs much better? You can see that the models I built 245 is like the one that is having the most reduced. At this point, based on what I have done so far, I can submit this lasso regression. All right. I can submit that one because the model performance is better at that point. When I say better, I mean I've reduced my error. All right. I've reduced my error. Yes, I think the data is there, but can me check? I think data is there. Yeah, the data is there. All right, that's what I did there. So I decided you can look at this now. So I decided to work with the one that performed much better. So I submitted at this point the lasso, right, over the other guy that I have. And finally was the assembly, like somebody asked the other time. What does that really mean? There are some models that we call boosters, right? There's some models that you cannot compare how much they're fast. Some of them are light and they perform much better. We have a number of them. We have your SG booster, we have your CAT boost, we have your light GBM, we have ADA. We have a number of them really. All right. And there is a way they also perform much better on your data. And at this point, I just used the SGB. I can see when I used it, it gave us 1148. That is reduced to, to a very good extent. So most time I advise because they are all boosting algorithms, you should try them out. Most times they perform excellently well, all right, on your model. But of course, you will not ignore the models that you're supposed to start with. Yes, somebody is asking, yeah, bagging and boosting, definitely, they can also help. All right. These are just techniques that you can also do. So somebody want to ask, at this point, what can we do? The other things you can do there is you can stack, you can blend, all right? That's the next thing you can do, especially when you know that you have model, because there are some points when you have tried everything you really can, and that's the truth. You might not be able to do more than what you can, how much you can think. Because at the competition is going, the time is going, you don't have all the times in the world. But at some point, you get like, this is like the end that I can do. This is the least I can, this is all I can do. Okay, try stacking. The models I've had before, can I combine their 3 results together and divide by 3? Most time it works too. All right. So the values I've had before, can I just combine them together? Can I just try this? At that point, you're not building any model. You're just trying to, try to do some little tuning to your model. So another thing you can also do is what we call our cross validation, where you talk about k-fold, all right, to just do your grid search, CV, all right. These are things you can do. Like I mentioned, you can build neural networks too. All of these things are experimenting. Yeah, experimenting, all right. And of course, what I've been able to show you here is how to build your first model, how to do some feature engineering, how to use different models, how to do your assembly modeling, that is using boosting algorithm. And of course, you can try other things. You can do your k-fold encoding, your k-fold rather. You can do your cross validation, your grid search, just to be able to find like the best tuning parameter. Not just, all these models now, we did not pass any serious parameter there. You can pass things, say, for example, you can pass the number of parameters. If you even do shift tab here, it gives you an option of what you can pass, into a model. But this one, you're just using the default parameter. We say parameterless library is what we are doing at this point. So I think we can stop here at this point. What are the best IDE to use because of the storing packages? So that also takes me to one other part. Thank you for raising that question. Most of the things I've done here have been on my system, but I advise that you get acquainted with other platforms that have amazing computing power. And one of them is your Google Code Lab. Let me try and look at for that. Google Code Lab. Google Code Lab. All right, so this is the platform. It has, amazing running stage, which advise that you try it out at your end, because you might also need to install so many libraries locally. So once you go to your runtime and you're trying to change the runtime type, it gives you other options, GPU, TPU. These are big things. And trust me, guys, these are big things. The system might not be able to run GPU, but you can have it on the internet. Same thing you can try out. So for me, I use this platform and I use my cargo kernel most time, because you might have very big data. The model might be taking, especially you have to do the light of grid search, because that will take a number of hours. Trust me, if you really want to follow those techniques, as it were. So I advise that you learn how to use Google Code Lab. You learn how to use Google Code Lab. You learn how to use your cargo kernel. These are like platforms that are so amazing. All right. So thank you, guys. I don't know if there are other questions, so I can stop sharing my screen now.
Thank you very much, Israel. Can you confirm on the chat box if you can hear me? Okay, so thank you very much, everyone, for joining this section. I'm sure it's been an exciting one. Okay, so if you enjoyed this section, I want to see you drop your favorite emoji on the chat box. I want to see your favorite emoji on the chat box, and I also like you to thank Israel for a job well done. Okay, he has actually took us through the rudiments of the hackathon, and it's not very simple. I'm sure that some of us can confirm that participating in this hackathon has become simpler. Yes. And so that's our aim. We want to be very simple, and we are here to support you anytime. As I earlier mentioned, that is a series, and it's going to continue. I just started today. It's going to continue. I'm going to have another section this week, Friday. Okay, so please, I want you to keep it. The flyer will be out so that you can see, you can have more details. And also, there's going to be a closed user group. Okay, some would have joined. That's our hackathon community on Telegram. Okay, so everyone who has registered for this event will be added to that group. Okay, so I just want to reiterate on this. And if you are yet to apply for the Mojo Hacking 23, can you do so with the link? I've dropped this link separately. And then you are expected to add DSN as a surface. Now, you don't add it during registration. When you are done registering, then you now add the DSN as a surface to your name as written here, Tejumala underscore DSN. So it will help us to actually track the progress of our community members. Also, local community, especially campuses and city communities, are expected to create a team, to form a team and participate as a community in this hackathon. So for every community ambassador on this call, your community is expected to have a team and then DSN. So probably the lead will register and then afterwards form a team on behalf of the community. So thank you very much for joining. Let me quickly check the chat box to see if there are questions. Yes, the question, was it now? The record will be available for everyone, especially those who registered for this. So the recording will be sent to everyone that registered for this event. Okay, so thank you very much. Thank you. Oh, lest I forget, we have Gideon on the call. Gideon is the country ambassador for Zindi. We're happy to have you on the call. So thank you everyone for joining, and then see you in the next training as we continue conversation on the DSN hackathon Telegram group. Okay, but before we close, let me quickly drop the link to the Telegram hackathon group so that hackathon community so that we can all have it. So let me just do that now, and then everyone can join. Only join with this link. Only join with this link. So thank you everyone. So do enjoy the rest of your day. Okay, so the link to join someone asked for the link to the hackathon to this training. So that's just bit dot ly dot ly esn underscore hint underscore. Okay, so that's it. Thank you everyone, and do enjoy the rest of the day. Bye. See you in the next class.